Hi, everyone. My name is Josh Stella. I'm the co-founder and CEO of Fugue. I've also been the CTO here. Fugue is all about cloud security and compliance, and I've spent about a decade of my life just focused on cloud security and compliance from an engineering perspective. So I hope you enjoy this presentation. It's going to be on thinking like a hacker, real-world cloud exploits in action. There are 5 slides total, including this one. So this is not going to be death by PowerPoint. This is instead going to be me mostly spending time in a web browser, showing you documents, showing you interfaces, and showing you how hackers actually think. All right. This is the whole agenda. Why we should start thinking like a hacker. So a little bit of background on why this is important and how it's useful. Then we're going to go into a deep dive. We've only got 30 minutes today, so it won't be as deep a dive as I sometimes do, but it'll be deep enough, I think. If you're not super technical, don't worry about it. We're going to explain things very, very thoroughly, I hope. If you are technical, we're going to get a little technical too. We're just going to explain them as we go. And it says Q&A here. We're going to have Q&A. This is a pre-recorded session. So normally I like that to be just interspersed through the whole thing. We're not going to be able to do that today, but certainly we'll get questions hopefully during the live session, and I'll be there and happy to answer them. Okay, in the cloud, misconfiguration of cloud services is the main risk. It's not operating system vulnerabilities. It's not application vulnerabilities. Often those are used along the way when doing a cloud breach. But 99 times out of 100, and I've never seen the 1 out of 100, 99 times out of 100, the real damage is done via misconfiguration of cloud resources and leaking of secrets. Okay, so many of these advanced cloud misconfigurations that get used, things like lateral movement in identity and access management services, complex chains of exploits getting to S3 buckets, things like that, they're just not considered compliance violations by the big compliance families. And Fugue, we support all the big compliance families. There's a lot of good stuff in there, but they're not always great at keeping up with the hackers. Okay, so this is the first reason you need to think like a hacker. And how do we do that? I believe the best way to do that is to follow closely what the hackers are doing. I often get asked, as the head of a cloud security company, what's the number one thing I can do and I should pay attention to for cloud security? And my answer is always, pay attention to what the hackers are doing. That tells you how these things happen. So most of these, or many, aren't really considered compliance violations by things like NIST and CIS, and there's a bunch of them, ISO, and I think we support like 1.5, 2 dozen of these families now. And part of the reason for that is they are often only apparent in the full context of an environment. So I want you to think about whether you believe the ability to list resources in the cloud is dangerous. So just think about that as we're going on. Let's say you have a compute instance or a container or a Lambda function that needs to retrieve objects or place objects or both in something like an object store, S3 on AWS or blob storage on Azure. Is it dangerous, in your opinion, for that compute instance or that piece of cloud infrastructure to have list access? And you're probably guessing now what I'll say later. But I just want you to think about that, because a lot of times folks think it's not dangerous. And that's because they're missing the full context. So a lot of the security tools out there can't examine the full context, and a lot of practitioners aren't studying what the hackers are really doing, and so these things create a false sense of confidence that you don't have an issue. We try very hard every time there's a breach to bake it into our product. But today is not about Fugue. Today is about teaching you how to think this way so that when the news happens, you can hopefully make some meaningful decisions about how you're going to respond and not be the next person in the news. This makes them very easy to overlook. The fact that they're often not in compliance rules, they only show up if you understand complex contexts in an environment. And because they're easy to overlook, they're very common. And this is increasingly exploited in major breaches. I don't know of a single major breach that is not due to this in the cloud. They're probably 90 out of 100, or 9 out of 10, are not divulged to the public, right? And so we don't know. But in the ones that have been, and by the way, in this session, I'm going to go through several real-world cloud breaches. So unfortunately, I have to name names because these are real things. The reason we're doing that today is that it's much better to look at what hackers really do than to do a bunch of hand-wavy, nonsense, frankly. So that's what we're going to do. Okay. So now we're into, I promise you there are only 5 slides. There's one after this. The rest of this session is going to be spent really going through these breaches. So here we go. Okay. The first breach/breaches we're going to cover are ones that happen to Uber. I mentioned we're naming names. I said that's unfortunate because a lot of times if you do that, people think you're criticizing those organizations. The fact is, as I said earlier, when I was a principal solutions architect at Amazon and since founding Fugue, this stuff is really hard to get right. So in no way am I saying that these organizations were necessarily neglectful or unskilled. You'll make your own judgments, but I can tell you some of them are some of the very best at doing cloud security, and so that hopefully makes you feel like that's a warning that if you're confident, you might be overconfident. All right, let's take a look at these breaches. We don't know a ton of detail about these because there just hasn't been the kind of disclosure that we would like to see as security researchers. So I'm reliant here on news stories, in this case from Ars Technica. I don't like being reliant on news stories. They're very often wrong in some critical details. I like it much better when there is, say, a DOJ filing. That's kind of the best. So given that to be the case, I'm just going to turn my speaker down here so we don't get ding sounds. Given that to be the case, there are certain things we can learn from in the news about these breaches. So let's take a look. All right. The very first explanation is that in 2014, Uber suffered a data breach after hackers found cloud storage credentials hard-coded in Uber source code that an engineer had accidentally published on GitHub. I've heard 2 versions of this story. This is one. The other is that it was in a private GitHub repo. I can't find that source today, but it was in Bloomberg. I just didn't have a chance to find it. That it was in a private GitHub repo, which is interesting. So let's take this apart for a second. If you're a hacker, how are you approaching this? What you really want are credentials, right? You really want credentials that will get you access to the cloud APIs, whether that's reading out of S3 or something else. There have been many cases in public GitHub repos, and GitHub has some features now that will help you avoid this, but don't rely on those. Because if you are storing creds, and if you have a lot of developers, I guarantee one of them has done this. You can tell them not to. They got their .ignore wrong, forget, or whatever, and creds end up in an actual code repo. And in this case, Those creds were then used to steal data out of S3. That's normally what folks are going for. That or spinning up crypto mining in your account are the two most common use cases I've seen for hackers. So this goes on to quote this fellow executive Sullivan here. I think he was the CTO. He elaborated that it was common at the time to write access IDs and other secrets directly into code when that code needed to call for information from another service. Do not do that. There are a lot of reasons that you should not do that. One is obvious. If they're in code, they're probably in a repo. If they're in a repo, you now have additional attack surface. Now, if we go back and think of this as potentially a private GitHub repo, it gets more interesting to think about as a hacker, right? Many breaches that happen, I'd say most, probably the vast majority, are not targeting specific companies. They're just looking for vulnerable stuff on the internet. According to an associate of mine who studies this for a living, the time between you putting an endpoint on the internet, like an IP address or a DNS name, and hackers scanning it for vulnerabilities averages around 7 minutes. So you have almost no time. Now, in the case of a public GitHub repo, and this is why very often hackers are not setting out to target an organization. They're collecting vulnerabilities through automation that they're constantly running, and then selecting almost like from a menu which of those targets they want to go after, okay? If it were a private GitHub repo, that means that the hackers broke into another cloud service, a different cloud service, to attack AWS. And that's another thing to be thinking about. Where are your kind of attack surface dependencies across different cloud services? I would also take a hard look at CI/CD pipelines and how you're getting credentials to those. So you might say, Josh, if we're not storing them on disk, where are we putting them? In a secrets manager of one form or another. The cloud services all have secrets managers. Wherever you can, which is just about everywhere, not for API, machine-to-machine API, but for human interactions, enable multi-factor authentication. Use that secrets manager. And there's another reason for this, which is why would a key that were checked into a GitHub repo still function days, weeks, months, even years later? The answer is lack of key rotation. Now, if you are checking keys in source code, if you're hard coding these things or config files, it is very unlikely that you are doing proper key management and key rotation for your credentials, because it's a pain. You don't want to update. I would say, typically rotate keys daily or even faster in many cases, depends on the use case. But you're not going to go and update all of your source code. Maybe somebody out there says, well, that's exactly what we do. Well, I would still argue against it. Bite the bullet, do a secrets manager. Don't try to do your own hand-rolled key rotation stuff if you can avoid it. It really is a pain. All right, let's look at another source that we might find credentials that are useful to us. So here Uber, it came out of their GitHub repo. There are other places you can mess this up, okay? One that is common are things like S3 snapshots that are left too open, right? So that's a disk image. Or even objects put into object storage that contain credentials. So Grey Hat Warfare, buckets.greyhatwarfare.com is a really neat little site that goes and examines. Remember I said the 7 minutes? Well, these are white hat. They say gray hat, but they're really they're white hat for the most part, as far as I know. Hackers that are going and examining all these public storage endpoints, and then collecting that data and making it searchable. Okay, so let's just go here. Like AWS buckets, Azure blobs, etc. And I'm just going to search for a .pem file, a PEM file. All right, and let's do a search. A .pem file contains credentials for logging into something. It's access key, secret key, etc. So in most cases, you would not have a legitimate reason for these to be accessible over the internet from gray hat warfare. There are, how many here? About almost 40,000 of these that it found. Now, I'm not going to pick on individuals here because, they are kind of gray hat in that they publish this stuff. So you might search for yourself here. But it's another place where you need to look for these keys. So if you're thinking like a hacker, what I'm almost always going for are your keys and credentials, or your credentials to access the cloud APIs to do things like S3 breaches and spinning up new infrastructure for crypto mining, etc. All right, let's move on to another breach. This is almost like the exact opposite, in a way, of the Uber breach, in that Imperva, when they were breached, did just an awesome job. This is their CTO explaining what happened in detail and what they did about it. And I deeply respect this. As I said, this can happen to anyone. Imperva themselves make a great security product in the cloud. Right, so we, Fugue, as a vendor in the security space, we are paranoid all the time about these sorts of things happening. They've never happened to us, but this is kind of what we do for a living, so I believe that will continue. But in this case, Imperva did the right thing. They notified folks, it got fixed pretty quickly, and then they described in detail what happened. And this is the right thing for a lot of reasons, but the one I'm most concerned with is I can learn from this. Right, in terms of protecting those resources. So what happened? The TLDR, their investigation identified an unauthorized use of an administrative API key. Hackers are going for the keys. In this case, an administrator API key. In our production AWS accounts in October 2018, which led to an exposure of a database snapshot containing emails and hashed and salted passwords. There was some other stuff in there too. Admin keys should be short-lived. I think it kind of goes without saying, right? Admin keys should be short-lived. So if you find one, if somebody slips up, it should be outdated. But let's go back into how it happened. They were porting a product, their cloud WAF, into some new cloud services. And they were leveraging Amazon's relational database RDS service. Awesome service, by the way. So some key decisions were made during the evaluation process that allowed information to be exfiltrated from a database snapshot, not from the database. Okay, not from the database. This is kind of the equivalent of somebody stealing your database's backup in the data center. That would be hard to do in the data center because who knows what kind of backup solution you're using or where those things live. In the cloud, totally different story. Database snapshots are stored in S3. Okay. So the decisions were, one, they created a database snapshot for testing. Okay, fair. Everyone, that's what you're going to do, right? Two, an internal compute instance that we created was accessible from the outside world, and it contained an API key. All right. Two issues here. One is that the compute instance was exposed directly to the internet with no intervening layers that would provide better security. I would recommend that you never do this. Anything that you're maintaining the operating system on is actually significant risk. So what we choose to do at Fugue is use services like Lambda as much as possible, keep everything behind gateways, keep everything behind layers of protection when you're talking about getting to compute. Because the compute instances, in this case, it said it contained an AWS API key. That might be it being on a disk. It also might be that it had access to a secret manager, or had access to the AWS metadata, which is a really nice way to handle these things. Okay, and what we're talking about here is, I'll show you a diagram here. This is our product Fugue. I'm just using it to show you around. We automatically diagram stuff. Here you can see we've got the internet going through an internet gateway, through a load balancer, to some EC2 compute instances in an auto-scaling group. I'm just going to select one of these. And you can see right here, the IAM role, okay, is the demo app role. That has privileges. That's how that compute instance, in this case, is talking to this RDS database. Okay, so, but we know that one, it was an administrative API key. They said that these things sitting on these compute instances should be really narrow in focus, only what the application needs. And two, they got access to snapshots, not just RDS. Why did why did this compute thing over here have access to S3 when it really only needs to talk to RDS? So these are very dangerous mistakes in terms of being overly permissive and also just not putting them together in the best possible way for an overall security strategy. So then 3, this compute instance was compromised, the API key stolen, and 4, the API key was used to access the snapshot. Now this is interesting to me. In the old days, right, in the data center, if you were trying to steal data out of a database, you would try to get into the database, the running database. I don't see much of that on the cloud. I see this more often. Either directly copying a snapshot or even taking a snapshot, which is essentially a backup, and constituting a new database cluster to exfiltrate the data from inside the customer account. That is super cloud native. You would never have a hacker get into your data center and then build a database cluster. Or maybe it's happened, but it seems like a very unlikely strategy. But in the cloud, because we lose track of things so easily, and that's why I'm a big believer in our product is visualization, so you can see what's happening. Lists of stuff don't always cut it. It can be really easy for these resources to be lost in the mix. I have never seen an organization that had 100% visibility and observability and knowledge of the infrastructure they were running. It's very common. We'll pull up that automatic generated diagram and somebody will say, what's that network and what's that compute instance running in? And this gets to another point, which is orphaned infrastructure, stuff you've forgotten about, is a favorite attack vector. It collects CVEs if you're not patching, so you forget about a server where you're maintaining the operating system, a compute instance or a container or something, if you're doing long-lived stuff with containers. And you have, ultimately, it gets stale because it's forgotten about. Remember, the hackers are, in an automated way, looking at all endpoints for things like known CVEs and misconfigurations, shows up in their spreadsheet one morning, and they gain entry into your cloud environment. The other thing you have to understand is that cloud hacking is very dissimilar, is very unlike data center hacking. I'm usually not really worried about defense in depth at the TCP/IP layer, the network layer, because it's very rare that my attacks are going to go through that directly. They're going to go against the control plane APIs. So the traditional defense in depth techniques in the cloud, you still need to use them, but they have just far less relevance to the real attack surface in the cloud, which is the API configuration and access layers. All right, so what did Imperva do about it? One, they applied tighter security access controls. Okay, I don't know what that means, but it's it's a good thing. Do that. Do that every day if you can. And by the way, I'm a developer and a software architect, not a security analyst / CISO kind of person. I'm a builder of stuff. But you really do need to have a good understanding of the security controls and have them be nice and tight. Through automation, the old human processes are pretty tired at this point. They can't keep up. All right, 2, increasing audit of snapshot access. Okay, so now they're saying, we need to pay attention to who can get to snapshots. I've seen this over and again. People just don't realize how much value there is to a hacker getting access to snapshots, which are in S3. And so they'll think, well, S3 access, read, what's going to happen? A lot. Everyone knows about stealing data. What you might not know is you can get disk images, you can get database backup, snapshots, et cetera, stuff with real customer data and so on, as well as API keys if you're doing it wrong. Okay, they started decommissioning inactive compute instances. Do this religiously. These things are constantly a component of breaches that we see. Rotating credentials and strengthening our credential management processes. Never put them in source code. Never put them on a disk. Mandate use of a secrets manager. Scan your repos. Scan your images. This is a very, very common way for hackers to get into your stuff. And by the way, you shouldn't be using overly permissive API keys and credentials in your running environment anyway. Like that EC2 instance, right, over here, if it doesn't need to talk to S3 buckets, don't give it permission to talk to S3 buckets. That way, even if a hacker gets in here and gets the current creds to use it, they still can't see S3, all right? So where were we? 5, putting all internal compute instances behind our VPN by default. I personally think VPNs are kind of going away other than for privacy use. There are other ways to, but what they're saying is no public IP addresses, right? I agree with that. If it has an operating system on it in the cloud and you're sitting it out there, you are asking for a hacker to find it, find something you missed, and end up in the news. I want AWS and Microsoft and Google, my cloud providers, to manage that stuff. They're way better at it than probably you or certainly I. And I've got a lot of background in national security work. They're very, very good at it. Okay, use that. Don't try to DIY this. And then increasing the frequency of infrastructure scanning. Absolutely. One thing we've seen over and again at Fugue, and I also saw at AWS, is let's say you scan an environment for vulnerabilities one day, and you think, well, it's going to stay roughly similar, right? No, it's not. It's not over time. And you might say, I've had people tell me, everything is done through CI/CD with CloudFormation or Terraform. I've never seen that be true. It is unrealistic, and it is not a way to expect that you will be able to manage keeping hackers out of your environment. Okay, unfortunately, that's all we have time for today. I've really enjoyed giving this presentation. Here's my email address. Reach out to me anytime. I love talking about these topics. I'm passionate about it, and I really enjoyed presenting to you. So I hope you have a great event. Thanks. Bye.